Welcome to the class, dear students. In today's lecture, I'm going to explain the infinite series, the topic infinite series. This is the topic mostly in real analysis, a very interesting topic where the series consisting of an infinite number of terms, we are able to find out whether it is the sum of the series is going to infinity or whether it goes to a finite value, what happens, or it is oscillates between any particular numbers. All these we will be discussing in this particular topic. It's a very interesting topic which consists of all the infinite number of terms. Let us say now, just I wanted to give you an example with, let us say if I have the numbers, let us start with 2 and then 4 and then 6 and then 8. Yes, you can start telling the numbers, that is 10 and then 12, like that. So you are able to assess the number here. Similarly, if I write suppose 3 and then 9 and then 27 and then 81. So when you are writing this, when I hope that all of you who are listening this lecture, 100% they are able to tell what is the next number. Yes, even if I say it is 5 and then 10 and then 15 and then 20, yes, you are able to tell the numbers. I am able to hear you. Yes, these are all the numbers. So something is following here. A particular formula is inside, is inbuilt in this numbers. What is that? The inbuilt number formula it is, so that you are able to tell what is the next number in this particular series of numbers, and it is going to infinity. As I told you, this is going to infinity. Whatever the infinite number of terms, you are able to tell what is the next number, like this. So there is a hidden formula in your mind what is going to be the next number. That hidden formula is nothing but when you multiply, that is 2, and this is 2 into 2 and then 2 into 3, 2 into 4, 2 into 5, like that. So can we say that this is a sequence of numbers where it is 2n, where n is equal to 1 to infinity. So in computer system, generally whenever we are writing down any in the computers, now whatever we are learning this infinite series, it is very much helpful for the data science. Always in the computer system, first of all, it should not take much place, right? So therefore we will give a number which is giving you an infinite number of information. That is the beauty of this sequence actually. Now if you put n is 1, you are getting the first number. When you put n is 2, you are getting the second number. When you put n is 3, you are getting the third number. Like that, this particular sequence is giving you the whole information of this infinite sequence. So that is what the sequence. Now here, let us see what is the formula which is hidden in this. It is 3 into 1, 3 power 1, 3 square, 3 cube, 3 power 4, like that. So the hidden formula in this is 3 power n, where n is equal to 1 to infinity. So you can say that even if I ask you what is n is equal to 100, then immediately you can calculate and tell. Even n is 1000, you are able to tell. So that means this formula, whatever you are writing, that formula is nothing but the function inside inside these this hidden sequence, you are able to tell. Now coming to this formula, what is the hidden formula? Yes, you are right. It is 5 times of n, where n is 1. When n is 1, you are getting the first number. When n is 2, you are getting the second number. 5 into 3, 5 into 4, and 5 into 5, and so on. So this is what a formula or a function which is been defining the whole infinite series. Wherever you get n is 1000 also, you are able to tell. Now let us go to next series, where 1 by 2, then 1 by 4, and then 1 by 8, and so on. So you can say now the next term numbers, and the formula inside here, what is the function here? It is nothing but 1 over 2 to the power of n, and n is equal to 1 to infinity. Okay, n is equal to 0 to infinity, let us say. Because when you put n as 0, I get 2 power 0 is 1 and 1 is 1. And when I put n is 1, I get second number. When I put n is 2, then it is a third number. Suppose if you want to start, we cannot say the zeroth number or something, right? So I write this as 1 over 2 power n minus 1. 2 power n minus 1 if I write, suppose, I can start with n is equal to 1 to infinity. I hope you could understand. So when n is 1, 1 minus 1 gives you 0. So 1 by 1 is 1. And when you put n is 2, you are getting the second number. When you put n is the second term, that is 1 by 2 power 2 minus 1, which is 1 by 2. When n is 3, 1 by 2 square. When n is 4, 1 by 2 power 3. Like that it goes on. So we are able to write down now what is the sequence. The sequence is nothing but the set of the ordered numbers, the set of the ordered sequence where you have to write down the numbers. So that means what? You can say that an infinite sequence, first of all I am talking about the sequence, okay? An infinite sequence is an ordered list, of some numbers, ordered list of numbers of the form, let us say first number is a1, second number is a2, third number is a3, and so on. So we can rewrite this as the sequence n is equal to 1 to infinity. Now the important term which you have to highlight is the word ordered. What do you mean by this ordered? Means there is a formula. Ordered means when you put n is 1, you have to get your first number. Like that you have to, we are able to find out, even if you put n is 100 or 1000 or 10,000, whatever goes to, then you can find out the number. If I say what is n is 100 in this, immediately you are able to say that it is 200. When n is 1000, suppose, you can say that in this sequence, when I say what is n is equal to 3000, you can say that n is the total 3000th number in this sequence is 6000. So whatever the bigger number you are able to tell, you wanted, suppose, you can find out this if it is an ordered. If it is not an ordered, it won't follow any particular rule, so that you cannot guess the number, correct? So therefore, what is the definition of an infinite sequence? Means it is an ordered list of numbers of the form a1, a2, and so on, an. And the term a1 is called as the first term, a2 is the second term, a3 is the third term, and so on. I hope you could understand now what is the infinite sequence. Now let us come to an important point, that when I write when I am writing all these sequence of numbers, are they going to, when I am going to give the number as n is going to infinity, that means as n is going to be a larger number, larger and larger, are you getting a larger number in this? Whether you are getting like this, so that when n is going to infinity, or these elements are also going to infinity, or is there any particular threshold where it stops the sequence? So if that particular number, it is not crossing that element, suppose, then we say that it is the limit of a sequence. So what is meant by the limit now? The limit, we have to find out where we can stop the sequence, at which number we are going to stop the sequence. Is there any such a particular number which stops this sequence? That means, let us say, what is meant by the limit means, if I say as limit n tends to infinity, the sequence, whatever the term an, is going to a number L, suppose. Then we say that if this L is a finite number, then we say that the sequence an is convergent. The English meaning of convergency means it is converging to that. It is almost going to that element, almost equal to that element. Then we say that it is convergent. If your limit L is infinite, suppose, if the limit L is infinite, suppose, then we say that that means it is not going to converge, it goes to a bigger number. When n is going to bigger, an is also going to bigger, and that is what called as the divergent sequence. So now you may ask me, since it is the sequence is a finite, it is consisting of an infinite numbers, definitely all of them goes to infinite numbers only. That is what your understanding may be correct. Yes, of course. But now let us look at this particular sequence now. When I am talking about this sequence 1, 1 by 2, 1 by 4 and 1 by 8, I wanted to see this now, okay. So the sequence, now let me write down the ordered real number. Let me write down my 0 and 1 are here. Now what is the, where half is located? My second term half is located here. Now where is my 1 by 8 is located? 1 by 4 is located. It is just in between of 0 and half, correct? In between 0 and 1, there is half. In between 0 and half, there is 1 by 4, correct? In between 0 and 1 by 4, there is 1 by 8. In between 0 and 1 by 8, there is 1 by 16. And in between 0 and 1 by 16, there is 1 by 32. In between, like that, when I am going, now what is your observation here? When I am taking the number, when I am increasing the number in the denominator as 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 16, I am closing and closing and closing to 0. When will it be, will it be equal to 0? Will it be equal to 0? 100% not, right? It cannot be 0, right? But when I give the number, and one more thing I will ask you, is it crossing the number 0? Is it happening to cross the number 0? 100% no, because you cannot get a negative number when you are increasing such type of a sequence. With the formula that I am having, that 1 over 2 power n is there, where n is 1, n is 2, n is 3, n is 4, but it never goes to a negative number. 100% sure that I can stop here itself. But can I stop at 0? That means, are you going to get a number which is almost equal to 0? 100% no for that also. Why? Because when I am increasing the number, it may reach to 0. My 0 will be here, which is outside of this region. Now the number is 1 by 64, and the number is 1 by 128, and the number is 1 by 256, but it never goes to 0. But only one thing we can immediately tell, we have a clarity now that this 0 we will never go, the numbers are going to 0 but not equal to 0. But we can say one more important thing, that it doesn't cross 0. What do you mean by this? This is nothing but, this is the border of the sequence. What do you mean by the border? Border means it never cross 0. What do you mean by this? This is what the limit of a sequence. So this particular number 0 is the limit. That is what the particular threshold for this particular sequence which stops at 0. So therefore we can say that what is the limit of the sequence 1 by n, we write here, right? 1 by 2 to the power of n, as n is going to infinity, the value is the value is 0. Understood? So when the limit as n tends to infinity here in this sequence, as n is going to infinity, this 1 over 2 to the power of n, it goes to 0. This is what you can say. This is what we say, that limit n tends to infinity, 1 by 2 power n equal to 0. So therefore we can say that the sequence 1 by 2 power n is a convergent sequence, because it's a convergent sequence. Why? Because we are able to find out a limit which is a finite. 0 is a finite number, correct? Get the sequence 1 by 2 power n is a convergent sequence. Now if you see these numbers, now as I am going to, n is going to infinity, now you see the real line, whatever n is going to infinity, it is going to infinite number of numbers. So as my n goes to infinity, this particular sequence 5n is also going to infinity. It never stops. And are you able to find out a particular number where this particular sequence sequence of numbers are going to stop and we can say that after this number it doesn't go? No, right? When n is 100, when n is 1000, when n is 1 lakh, we are getting all the numbers as n is going to be a bigger and bigger and bigger. My sequence is also going to a bigger and bigger. So that means it says that it goes to infinity. So the limit of the sequence is infinity. So this sequence is what? It's a divergent sequence. This is what you can understand. So that is about the sequence. What do you mean by the sequence and what is meant by the limit of a sequence? Thank you. In my next class, I am going to explain you what is meant by the infinite series and how to find out the limit of that infinite series also. Let us wait and watch. Thank you.